Fire away.
All right. So on November 2nd, which was about a week ago now, Heroku performed some maintenance on our database, which involved swapping out our database for another database. And immediately afterwards, our performance went in the toilet, as you can see from this handy chart here. And that was no good. But, and you can see that we're up to like 15 seconds to load the main page. It's not good. And so I had a little back and forth with Heroku and kind of did some research and figured out some stuff to do to make our performance not suck. And this is just a list of things that I did. The first thing I did was I vacuumed our database, which is apparently a thing. When you delete rows from the database, it doesn't actually delete them. It leaves kind of like blank space, and so it takes longer to traverse through the tables when they're searching them. And so I found out about the pg bloat command, which tells you about all the tables that we have and how much bloat they have. So you can see that like Ahoy Messages has a whole ton of bloat. We've got a lot of bloat in our search vectors and our drafts. These are tables which have lots of rows added to them and also lots of rows deleted to them. So I vacuumed some of those up, not all of them. And that didn't have much effect. So the next thing I did was I added an index to the drafts table. An index is basically a smaller version of a table that makes it easier to look up information in it. And we look up drafts a lot, as I'll talk about a little bit later. And so adding an index to that table actually sped up our performance quite a bit. The next thing I did was I made drafts save less often. I don't know if you can see that there, but basically I'm typing a sentence into our our new thread form. And on the right here, we're getting a whole bunch of requests that are saving the draft. And I'm typing a simple sentence here, and it's sending off 14 requests to the server. And so you can imagine that if we've got like, 1,000 users on the site at the same time, and they're all typing comments at the same time, then all of those requests are going to the same endpoint and hitting the same database table at the same time. And that was a big bottleneck. So the thing that I did was I lowered the debounce from every 300 milliseconds to every 750 milliseconds. And that took us from about 20% of our overall time spent updating drafts to it's down to around 16% at this point. And you can see in this graph here, we went from kind of like lots of erratic behavior around saving drafts to nice and thin and easy over the course of a couple deploys. The next thing I did was I stopped storing physical backups because Heroku told me to. And that had a noticeable effect as well. I made some query improvements, which I won't go into. Yep.
What's physical backups?
So we're running a job every day to save an entire copy of our database. And the Kaiko, the guy from Heroku, said that's actually slowing down your performance because we recommend maximum 20 gigabytes of size for backups. And he also said that they protect your database with continuous physical backups on their end. So they said to stop that job. So I did that. The next thing was that we just moved our database over last night. There were a couple of interesting things about that. One of them was that we were on a multi-tenant database, which actually means that we had neighbors, and those neighbors' activity affected our performance. So we'd actually have cycles during the day where, because somebody else's site was having a lot of activity, it was slowing our site down. So we moved from a multi-tenant to a single tenant database, which means that we have a certain like box to ourselves. And we also upgraded to a higher tier database. So we went from 1 gigabyte with 64 gigs max size to 3.5 gigabytes and I think 200 gigs max size, which was good because we were at 54 gigabytes and growing, which means that if we ended up over that, then everything in the app would crash and no one would be able to do anything. So it was good to avoid that. The other interesting thing that I learned was that we've got a couple of key numbers here, which is the overall index hit rate and the overall cache hit rate. These are the two primary indicators of how well your database is doing. One of them is how often you hit indexes, those smaller tables that I talked about earlier. And the other one is how often you hit the cache, which is a function of how much memory you have. And the recommended numbers for that were 99%, and we were down at 96% and 92%. So we did some indexing work, and then upgrading our database took our cache over 99%. So these are no longer problems. They don't show up in our problems list anymore. And you can see that the final result of all of this stuff was, here's November 2nd when everything went in the toilet. And we had some ups and downs and crazy activity. You can see some of the spikes here where our neighbors were having a lot of things to say about our performance. And then here we are now. This was the 6th of November, and it's kind of stayed at about this level, which, as you can see, is about the same as we were before. And actually, since we've upgraded our database, which is after this, it's taken a slight dip down from there as well. So this is about 1,000 or like 1 second average load time, and now we're down to about 600 milliseconds. Yeah, that was my performance journey over the past couple of weeks.
Wow.
Well done.
Incredible.
Amazing.